Hello everyone, so today we are going to discuss about the Acyloin condensation. Now in this reaction, the product is alpha hydroxy ketone. Now what is alpha hydroxy ketone? So we can see ketone is written here and another part is alpha hydroxy group. So I am going to draw a ketone functional group, and at alpha position I will keep OH group. So this is what we call alpha hydroxy ketone. Now in this reaction the starting material is ester, and when you add in first step any metal like sodium metal, lithium metal, which gives out one electron, and in second step you can use mild acidic medium to get your product, which is nothing but alpha hydroxy ketone. So at alpha position of ketone we have OH group. This is what we call alpha hydroxy ketone. So in this reaction we convert ester into our product using sodium metal, which gives out electron. We will going to see them in reaction mechanism, and in second step we use any mild acidic medium. So now let's go ahead and write the mechanism for it. So I'm going to write the general reaction once again. So we have ester, sodium metal and acidic medium. Now here we use two molecules of ester. Okay, now we know that sodium is going to give out one electron, and electron, this is a delta negatively charged, and in ester we have delta positive carbonyl center. So this will attack at this center. This carbonyl bond will break and this will form oxygen bearing negative charge and one electron sitting at this carbon. Similarly, another molecule of ester will come. In the same fashion, this will also open up and we have another molecule with an electron. Now these two molecules will come closer and they will combine. Now at this position, we know that alkoxy group is a good leaving group. So this lone pair of electron will collapse, this OR group will leave. Similarly, once again here, and we will form the 1,2 diketone system. So you need to remember that in Acyloin condensation, the reaction intermediate, which can be isolabile, is 1,2 diketone system. So for now, this is what is our intermediate. So we have 1,2 diketone system, and we have bunch of sodium metals in our reaction, which will again come into picture, and the similar kind of reaction will once again happen. And we generate two radicals. They again come closer and form a double bond here. Now in second step we use acidic medium, so this O minus will get protonated, and if you look closely, now we have generated an enol system. Okay, this is an enol which will tautomerize to form ketone, more stable form, and this is how we got alpha hydroxy ketone starting from an ester. Now let's quickly go through the entire mechanism. So we have an ester molecule, we have sodium metal. We know sodium gives out one electron. An electron is a negatively charged species, So this will attack at the carbonyl center, which bears a delta positively charged and opens up this carbonyl bond. Now these two radicals come close, form a bond. Later on, this alkoxy group leave when this O minus comes back, and we form 1,2 diketone system. And when we have 1,2 diketone system, similar type of reaction once again happens. Electron attack at this carbonyl center, opens up. These two electrons form a double bond, and under acidic medium, this alkoxy group get protonated to form enol, which tautomerize to form alpha hydroxy ketone. Now let's go ahead and solve some problems. But before that, I will give a short trick that how to immediately predict the product of a reaction. Okay, suppose I have this reaction. I'm writing a general reaction. So how to write the product of this reaction in a minute? So if they have given one molecule, you have to automatically consider that 2 molecules of this ester is present. So let me write the 2 molecules of ester. Now to immediately predict the product, you have to ignore this OR group, and you need to connect this carbon with this carbon and convert this carbonyl into OH. So let me write what I'm saying. So I need to ignore these 2 alkoxy groups, and I need to connect this carbonyl with this carbonyl and convert this C double bond O into OH. Okay, so I'm connecting this with this, and this carbonyl is now OH, and it is connected to R1. So this is how you can immediately form the product of any reactions. Now there can be different possibilities depending upon the different R group attached. So first possibility can be the first possibility is when the R1 and alkoxy group all having the same R group. So the product will be, so connect this carbonyl center with this and convert this carbonyl into OH. Okay, now the second possibility can be R1 is same, but the alkoxy group is different. So in this case, the principle of predicting the product will be same. Connect this carbonyl with this carbonyl and convert this carbonyl into OH. And you can immediately write your product. So in these two cases, we get the same only one product. But there are some different cases where you get multiple products. So let me write the example of that. Okay, so the third case, for example, this reaction. Where we have same alkoxy group but different R group. So in this type of reaction, we get total of 4 products. We get 4 products. Okay, so let me write this molecule as A and this molecule as B. So when we have 2 different R group, we get 4 products. The first will be when A combines with A. The second when A combines with B. The third is when B combines with A. And the fourth one is when B combines with B. So the idea will be the same. So A combines with A. So let me write 2A. So the product is going to be this combines with this, and this will be OH. So this is one product. Similarly, If I want to join A with B, this will be connected to this and this will get converted into OH. So the product will be this will be my second product. And the third case is B connects to A. So this will attack here and this will convert into OH. So the third product will be so this is my third product. And the fourth product when B combines with B, and that will be this one. So I have discussed all possible questions you can get depending upon the similar R1 or different R1. Okay, just for example, if this R2 is also different, let's say we have R1 in A and R2 in B, then also we will get the same four products, because while producing the product we are anyways ignoring the alkoxy groups. So these are the four different variations you can think of. Now one more thing I want to discuss is intramolecular Acyloin condensation. So we know when ester combine with ester, it forms alpha hydroxyketone when we do Acyloin condensation. But what if the two ester group is present in the same molecule? That is what we call intramolecular Acyloin condensation. So let me write one example. So this is two ester molecule present in the same molecule, and if we do the Acyloin condensation, the idea will be same. Connect this molecule with this one and replace this. So it will be 1, 2, 3, 4, 5. So we are forming 5-membered ring. Okay, and we have to ignore these two, and we need to connect with this and convert this carbonyl into OH. So this will be the product. So ignore these two alkoxy group, connect this two carbonyl group and convert one of them into OH to get your product. So this is what we call intramolecular Acyloin condensation. So now let's solve 1-2 real life problems where you are going to actually see the alkoxy group like benzyl, ethyl and things like that. Okay, so feel free to pause the video and try this reaction by yourself. So these two are the starting materials. We have two esters and we are using sodium metal with acidic medium like acetic acid. So pause the video and predict all the product and try it by yourself. Okay, so let me write this molecule as A and this molecule as B. So A will react with itself, A will react with B, B will react with A and B will react with itself. So we will have 4 products. So the product A will be A reacting with itself and the product will be now the second product is A reacting with B. So connect this center with this and convert carbonyl into OH. So we have ethyl group here. Now the third is B reacting with A. So I connected this center with this and converted this carbonyl into OH. And the last is B reacting with B and the product will be. So these are the 4 products we can get by reacting these two different ester molecules. Okay, so this is another 2 problems. You can pause the video and try it by yourself. Okay, so let's solve it. So we know the starting material is ester. We see the reagent metal and acidic medium. So we can immediately know that this is an Acyloin condensation. So to make the product, as I said, 2 molecules of ester will be reacting. So let me write my 2 molecules. Connecting this with this and converting this into OH. So the product for this reaction is going to be this molecule. Now this is an example of intramolecular acyloin condensation. So the idea will be same. Ignore this two alkoxy group and connect this with this and convert this carbonyl into OH. So the product is going to be 1, 2, 3, 4, 5, 6 membered ring. One is ketone, and at alpha position we have OH. So this is alpha hydroxy ketone. So thank you for watching.